Yes, project engineer at CDI. So these are my details. So first, basically for starting Android vulnerability assessment or security testing, we need to so basically for starting vulnerability assessment, Android app vulnerability assessment, we need to be thorough with the following prerequisites. Basically, you need to understand the mobile app Android architecture. So basically, you need to know basics of the Android architecture. Like Android is basically based on Linux, so you need to be hands-on with the Linux command. Then Bob Suite is a tool that is being used to intercept the backend APIs. Whatever when we click on some button or something, the request goes, and for capturing that request, we need a Bob Suite. This is the tool that can be used. So basically, you need this good system with all this requirements. So start the audit or the basic assessment. So for basically assessing an Android application, you need to have an APK. APK is basically the thing you install from the Google Play Store. So full form is Android Application Package. So like first, for setting up this up, you can use a real your device or a virtual device, that is a Genymotion device, or even you can root your device using custom ROMs that are available in the market. And for like assessment, you need to have one more operating system that can be installed on your VirtualBox, Tamers, onto Mob Elixir. So if you're using Windows, even you can install API directly on Windows. Through this, you can start with the assessment. So basically, first we need to know that the in which language the application is being developed. Like mostly it's being developed in Java, C++, or Kotlin. And recent applications, like everyone is using updated mobile phones, so the versions of it are Oreo, Pi, and Android Q, and like that. So the frameworks that are being commonly being used by organizations to develop these applications include Xamarin, Ionic, PhoneGap, and Cordova. So what they do, it is mostly some of these frameworks are language independent and like easy for them to customize for different version of OSs, and if even for different devices, they can like customize this thing using these frameworks. So basically understanding the Android architecture. As I told that basically Android is based on Linux kernel. So like the base is this, that we have the drivers, Wi-Fi drivers and everything in Linux. Above that, we have the libraries. This SSL library is basically for secure communication over HTTPS. So all these libraries are there. Then there are SQLite library for database and all. Then OpenGL is for graphics and all. These kinds of libraries are there. Further, you can see the frameworks are there: window manager, activity manager, package manager, this telephony manager. These are the package manager packages for like different functionalities like calling, for handling the backend and location, resource, and all. And the final applications are the ones that we use, like the contact. These are the basic applications the device has. After that, you can install from Play Store other applications you want. So basically, when we get a APK file, we can like do analysis of what the APK file is containing. So for this analysis, you need to know about the like internal architecture. We can like decompile or like extract the contents of the Android package structure. So like basically after extracting the contents, you will find this following type of contents, like Android manifest file. So basically, like what in previous session we gone through the permissions that are being set. So the while developing, the users set these permissions using manifest file. So these are there in the manifest file, permissions and components, and all these details are there in the manifest file. That is written in XML language. So basically, after that, there is a libraries like depending on your version of the phone, like it's supporting x86 architecture or x64, something like that, or even the tablets using MIPS. And most of the devices in the market are ARM-based architecture. So these are the files that will be there. Depending on the type of mobile you are using, it will be there, and the type of support the application provides, the libraries will be present in the application. And the other assets includes the components of the application. And the .dec is basically Dalvik bytecode. It is basically the code or the thing function that provides the functionality. Smalley code is in the assembly language. So Android app components. Basically, the components are like intent, activity, services, broadcast, receiver, content providers. Activity basically provides the user interface. That is the thing that is visible to you at front end. So whenever you click, you are clicking on one activity, it's transit to another activity that is there. And when you click on one, something in background happens. That is basically a services in backend that will work. And when the services, like you click on some application like music, it will start the music. So if you are listening music online using like Spotify or something like something YouTube or something, so it will fetch data from backend using broadcast receivers and content providers will and content providers. It basically stores some point of buffer or like content on your device. Basically, it is that. So for analyzing, so same whatever I told. This is the what the application looks at the developer end. So basically, this all are the components of the files. So like you can try to check for this all these things. So basically, what happens is sometimes in this coding, while doing source code, some people try to hard code information. Like they store the information hard coded. So if someone decompiles, he can get the internal hard coded data that should not be there. So we should avoid hard coding data inside the applications. So I will show you one demo. Yeah. So see, basically, yeah. So here I am showing you the basic thing. First, I am using my setup on VAPT setup. I am using a demo application for this. So see, this is the demo application. You can take APK of the application you want to do security assessment. So see, using the file Linux command, we are checking the contents of the like we are checking what type of the file it is. So basically, it shows that it is a zip file that is compressed. All the code and everything, images, resources, everything that I talked about previously are stored and compiled into a single APK. So this is the format. So further we will look into practical how to decompile this. So basically for decompiling this, I'm using tool. So basically I have installed API on Windows, and after that there is a tool called APK tool. Then APK tool /d as shown. Then we write the name of the application, that is Androgoat. See this way. Then we give the output folder. -o is output, and output folder name test we are giving over here. So this way, see it decompiles. So see this way it decompiles. It take time to decompile using this. So see this has decompiled now. Fine. See. So further we go ahead and like go into the test folder and check the contents. See, we go into the test folder, then ls command. See the way I was talking about the manifest file. This is basically that manifest file that contains the basic permissions and the details of the applications. You need to analyze each and every. First, we are looking at the manifest file over here. See, manifest file, it gives the complete details, like the package name is there, OWASP this is the Android demo application for OWASP. OWASP is basically open web application security project that provides these details, give the common set of vulnerabilities that are there in the application. So every what happens is OWASP give list of top 10 security vulnerabilities that are commonly found in the application. So basically, last 2016, the OWASP released the top 10 vulnerabilities for mobile applications. So based on that, we basically assess the applications. So first, like while assessing the manifest file, we check for the user permissions that are given. Like see, external storage is given. Then there is a allow backup and set Android to debuggable. This Android should not be set to debug mode. What happens is if it is set to debugging mode, so like a person who is hands-on with coding can try to understand the code and try to do some malicious activity with the using the debug. He can get into the backend internals and try to exploit your application. So it's a good practice in production ready application or Play Store application. Debug is mostly turned off because it is not required. And even backup, even that facility is not required, that also needs to be turned off. And further, we see here the network security configurations. These are need to be taken care. Configuration gives details about how the application interacts in backend. Like if it is using HTTP protocol, clear text, that is not recommended. So that kind of things needs to be avoided. Even if it is maliciously sending data to some other URLs, that can be checked using this network configuration rules and files. So basically, all this we need to check. These are the basic type of testing we do. So further, I will continue with the PPT. Basically, I was talking about OWASP top 10. So OWASP top 10 is giving you the M1. M1 is improper platform usage. What happens is as an operating system, Android provides a platform. But if you if the application Android application is not using the features properly, so it leads to like some vulnerabilities. Like what happens is Touch ID being properly not implemented by the application, if the coding is not done properly, or the activities are not securely implemented. So it leads to vulnerabilities into the application. To mitigate this, so basically what happens is like we need to store sensitive data in Android keychain. Android keychain is a safer way to store this data. And so for like malicious activities, we need to set export to false. If we don't require to export services and broadcast that are not required, we can set it to false. So malicious services and backend broadcast receivers will not able to interact with the application if not required. Similarly, we can check for the file permissions in the APK, like mode readable or mode world permissions and all. These all permissions are important. There we move next. Yeah, insecure local storage. So basically, insecure local storage is what is like what happens is in a normal mobile, we don't have root permissions. So like a normal person can't get into the backend of a mobile and check how the application is storing data. But when it comes to malicious users and hackers, they have rooted mobiles and they install application on rooted mobiles. So they can like when you log in into an application, it gives you user ID, password, and all. If that is stored in a clear text in a rooted device, we can get into the using rooted device. We can get into the internal files and files and folders of an application on the device. So by connecting to that, we can like check the internal shared preferences and all, and we can get the sensitive username and password or how the application is storing data in database. That all things we can extract, and even we can try to call activities maliciously. And also the using the log files, like what happens is at runtime logs are being generated by using ADB logcat. So that happens is that if even if the logs in production ready application, logs should be disabled. So this kind of thing you need to do. Yeah. Further move ahead. Mitigation. See, shared preference. Whenever you are storing data on a shared preference on a device, it is should not be in readable mode unless explicitly required. So what happens is if you start it as a readable, other application will try to access that data. And the way the like you are using some application and the application is storing your details as a database like password and username. So when they are storing this on your mobile device, it needs to be using ciphers. It needs to be encrypted, right? So this kind of things needs to be done. For encrypting, you can use this crypto libraries and all. And even we can avoid logging information, like logs should not contain the application data, like whatever you are typing or whatever you're doing, if it getting logged into the application, into the logs of the device, then it can be used by some another application in background, running in background, and it can take advantage. So this all permissions and settings we need to take care. Next, insecure communication. Yeah. So basically, I was telling you that while applications are developed, it should needs to follow HTTPS. But most of the application communicating on HTTP protocol, and even if they are using HTTPS, they are not setting the certificate or SSL pinning that needs to be done. So, like I told you, like there is a tool called Bob Suit. Based on that, you can intercept and check the backend communication. So to avoid this kind of things, you can set up SSL pinning and all. Yeah, SSL pinning basically means having a self-signed certificate, X9 digital certificate, rather than the normal HTTPS. That will help you to like secure your communication, and it's bit difficult to bypass this. And even you can avoid unnecessary certificates that are not required. This is all the HTTP, ORG, Apache, and all. Then host name and all. So and this is the classes that we need to check the method is properly implemented. Further, insufficient cryptography. Like what happens is, even like I told, if you are not storing on clear text in data on database is not storing on clear text. Even if you are using cryptography, sometimes you are using using sorry. So sometimes you are using cryptography, but algorithms and or you are using are like outdated one, MD5 or something like. So you should avoid that kind of things. And further, proper key private key should be maintained. It should the like cryptography should not involve only public keys. It should involve private keys also. So this all care needs to be taken. Further, we go ahead, like insecure authentication. Like what happens is sometimes the application is hard coding sensitive password, local storage or application. So like if someone like I showed you using APK, if you decompile that application and if in the internal files, if you find that password, default passwords and all being hard coded, then using this they can bypass. Or even if proper protection is not implemented, someone can like try it multiple times, brute forcing the application, or like trying multiple times username and password combination using using multiple tools are available. So they can try for SQL injection and bypass the authentication method. So proper checks needs to be implemented for this to take care. So mitigation, like what happens is only setting a password is not sufficient. You need to have multi-factor authentication, like use of OTP, MPIN. Like MPIN, what happens is like after a point, if your session expires, you can set a MPIN. Using MPIN only, you will get the back into the application. If you don't enter MPIN, even after authentication, also it will give a pop-up to enter MPIN. So multi-factor authentication plays an important role when it comes to important banking applications or some critical applications. So no one can try to, even if you have left your phone logged in with some application, if it is having MPIN and all, it is completely secure. So no one can get into the application even if they get your device. So this kind of server validation and client side validation needs to be done. Further, insecure authorization. What happens is like there are two users, like one is the admin and one is normal privilege user. So like what happens is normal privilege user should not able to access the data of an admin privilege. So for this you need to take care that proper authorization, like the proper authorization is being done, so that one person is not able to access admin features and all. So this kind of thing can be done. So IDR basically refers to IDR is like insecure direct object reference. So basically these are what is that is what I discussed. like a normal privileged person is trying to access admin roles. So basically this happens because of the ID or vulnerability. Like there is some parameter value. If you change that ID value normally in application, like some ID is defined given to a particular ID is given to a normal user and particular ID is given to admin user. So these IDs need to be encrypted and like not be guessable. If someone guesses that ID and manipulates that ID and gets the admin role access, that is very critical thing. So proper things should be implemented. And even IMEI number should not be used as a cookie. When you log in into application, you get cookies. That cookie should not be the IMEI number of your device. If that is being used, it is easily spoofable. People can get your IMEI number using some script. So always be careful not to click on any links, malicious phishing links. So you need to be little careful about all this. And like basically privilege, it happens between like I am told, like even normal vertical and horizontal privilege escalation things should not happen. So mitigation. So for mitigate to fix this, we use JSON Web Tokens. JSON Web Tokens are secure implementation of in the application. So basically, it is more secure as it has feature of adding private key. So even if someone gets your cookie value, if the proper algorithm is implemented, they cannot decrypt your tokens, and it's become difficult for them to break into the application. And for like after login, everyone gets a access token in the backend. So this access token should expire like after 30 minutes of time or like 60 minutes of time. So if the access token expires, so it's a good practice. You are automatically logged out of the application after inactivity. And like I mentioned, that admin and normal user should not able to access each other's features. So proper access control for different roles should be provided, and it should be checked at runtime that if some malicious activity is detected, it should be like network admin should get some alerts. Client code quality. So like developers need to keep this thing in mind while developing a code. Like they should follow the software development life cycle. What happens is security testing is done mostly at the end. So in case of that, if we start security coding practices, make this as a discipline, like we implement secure coding practices at initial stage and consider this parameter as the requirement while developing an application. So it will be like we will have more secure applications. Mostly after like completed developing application, then come to for security assessment and all. So this should be avoided, and secure coding practices, if implemented from start, this will help you to like reduce the risk of the code quality. And like I told, like what happens is like while coding, they are using framework, they are using some frameworks, and then frameworks you are developing the application. And what happens is while coding, they hard code or like they give information that is sensitive, and while we decompile we get these details. So it's basically we should avoid storing data in string parameters. So this can be accessed maliciously by, and like someone can get your personal identification. I found some details like Aadhaar card details and everything being by stored by application. So we need to take care that developers does not store this kind of things directly into the application unless required. And even if they are storing, this needs to be proper encryption and all. And we can use for how do we check that if the client code quality is good or not? We have some open source tools like Findbugs. Findbugs is basically open source for Java. Like analyze the client quality, code quality. You can ask your developers to check the code quality. Even there are paid tools for this, so it depends on your use. For the code tampering, what happens is after developing the code, it is formed, an APK is formed. And while APK is formed, we give them a signature and like certificate. Like based on that, the APK is further circulated from Play Store. So you should avoid installing application from untrusted sources. So what happens is someone can tamper the code and redistribute your APK. So this should not happen. So in case to avoid this, proper mitigation should be done. So like malicious, sometimes what happens is similar, like WhatsApp is there. So it was previously what happened is WhatsApp, there was a similar malicious APK with similar name, but just a word was like in small letter or capital letter. So you need to take care. Yeah, I got some question. So okay, sir, do we need to get source code from manufacturer to analyze his device, maybe router switch for security analysis? Uh, Source code will, no one will give you a source code for application. Source code basically you can't get from for application. If you are generating, if you are developing in-house organization application you are developing, then you can have a source code. But a different manufacturer, like a remote application, they will never provide you a source code unless it is a open source or like something. So source code, if the or if in your organization the application is developed, then you can analyze the source code. Otherwise, other applications source code, you need to do reverse engineering, and that is bit critical. So source code analysis can be done if the app is developed in your in-house or in your organization only. Remotely developed apps, source code analysis is not possible unless you get a permission from them to they provide your source code directly. Then only you can like do source code analysis. Okay, how to test device for security requirement? Basically, this basically OS level checks you need to do. Yeah, so basically, first we need to develop our own ROMs and all. So if we develop that, then only we can like be more secure. Like most of the users are using Redmi and MI. So then the ROM is itself is Chinese. So first of all, we need to start developing ROMs. Best practices you can use Google's ROMs are there. That is good enough. If you want to, for testing device security, basically you can't test devices. Basically, you can use Google Pixels and all that are more secure ones than the Chinese. So this is all I can say about this. Further, we move ahead. Yeah, signature check demo. Yeah, fine. I will show you one demo. Here, basically, we are checking the signature of the application. See, so I'm using key tool command. Using this, we check the signature of the application. Here what happens is like the complete details of the organization, owner, and all the things come. If it's a production application, it will all the details will come. This way, you can differentiate between a malicious application and a normal application. So this is the thing. Even you can resign applications malicious. You can resign malicious application malicious way and check if application is detecting fake signature. So a fake signature can be detected. So that kind of checks needs to be done. Further, there are tools called jar signer. Like jar signer is there. Tools like jar signer. Even this you can use to like check the do security testing and all. Okay, fine. We'll move ahead with. Yeah, so like how to avoid code tampering and all. First of all, application should not get installed on rooted device. So there should be proper checks implemented in application that it's not getting installed on rooted device. And second check is that application signature. So once we sign and distribute the application with a signature, if the someone resigns that application, you should have a mechanism to check if that application is resigned. You can get alerts. So basically, that kind of check you need to implement in the code itself. That application signature is checked at runtime. So if a fake signature based application is connecting to your server, you will get automatically like stop it from connecting as the certificate is fake. So that kind of checks you need to implement. So code checksums and integrity checks and all you can implement for this. So basically, I was talking about reverse engineering. Like you want to test code of some application that does not provide a source code. So for that, you need to, like I showed you in the beginning, the .dex files were there. The .dex files, um, .dex files, what happens is you can convert to jar using dex to jar command. Sorry, dex to jar tool that converts .dex file to jar. Once that jar files are with you, you can use the tool called JADX GUI to check the Java source code. So basically, this will happen if the proper protections of code are not implemented. Mostly, so you can get a overview of the source code of an application this way. So like even we have library files inside I mentioned. So even sometimes what happens is in library files also .so library files get stored in the application once you install application. So this .so files, some information is even hard coded in SO files also. So if someone analyzes SO file using Ghidra tools, this is an NSA based tool. So they can like do reverse engineering and gather hard coded information. So hard coding or information is very critical thing. So avoid hard coding information into an application. So extraneous functionality. So basically, some hidden backdoor functionality that is basically available for a developer should not be there in the production ready application. So avoid giving backdoor exploits to users. So this kind of things also need to be checked. Further, we can do penetration testing. We can do root partition checks and all. For this, we can use tools like Frida and Exposed, etc. Okay, this is done. Thank you. So for this Android, if any questions are there, let me know, or else I will move ahead with the iOS part. Any questions? Okay, fine. I will move ahead with the iOS part then. Just wait a minute. I'll just configure my things. Yeah, so I will start with the iOS. So basically, the iOS is the mobile operating system developed by Apple. So it's exclusive for its hardware. So even it's nothing is open source. It's like like a closed community. So it's like there are limited resources available for iOS. So like iOS basically means iOS. So basically, the iOS is developed for iPhone and touchpad and all. So basically, iOS architecture is based on Unix. It's a mobile version of iOS, OS X, sorry. So it's a layered architecture that has system interfaces. So further we go into the details. Like we get here the application Cocoa. Then there is a layer called media. So this core services are there, and upon that there is a core OS. It will consist of the libraries, and below that there is a kernel and a device drivers. So basically, currently the iOS architecture is not open source. This is the old architecture that I am giving you in detail. So currently, they have like closed these things. Yeah. Further, you look from an application point of view. So application runs over the OS, and OS interacting with the hardware. So it's like this. And the frame kit we are using is Cocoa Touch basically. This all is there. And below that is the media layer that consists of the graphics, audio, video. And the core services includes the address book, core data, location details, and all. And further it goes, we go down, it's Bluetooth and security, local authentication and all, right? So the basic layer, architect hardware layer. Yeah, so further iOS basics. So like in Android we have a APK file, here we have a IPA file. So basically when you install from iOS store, you get the iPhone application archive. So basically this is also a zipped file. So basically mostly it is developed in like Objective C and Swift code, and the integrated development environment for iOS coding done for iOS is done in Xcode, and this Xcode is available only in a MacBook. So if you want to get involved into iOS security audit and like iOS development, then you need to have a MacBook. So everything it's here requires having a MacBook dependency, an iPhone dependency if you want to get into this. So basically, iOS applications are based on a modern view controller. So here what happens is, like every time you update something, it will go to the model, then it will notify. This is the way this cycle moves on. So model view controller further. Yeah. So like iOS security controls, what happens is first we have a bootloader. So root CA is their certifying authority. Root CA it checks for the that hardware is proper and everything. Then it gets the user ID and group ID for the applications and all. And after the lower level bootloader configuration done with the Apple's root certificate authority, then we go into the booting process. And even the iBoot is signed by Apple, so we can see how secure the process is. Again, after that, there is a signature verification of kernel happens. So being an enclosed environment, it is not open source, so it's like lot of security involved even in the booting process also. So like after that, even the iOS signatures or application or signatures are also being assigned by Apple, and that is very kind of verification is done. So for like checking whether the application is signed or not, that checks are there in the iOS by default. In for Android, that checks are not there, but for iOS by default it's more secure comparatively, and even the sandboxing is there. And similarly here also we have keychain and file encryption based storage. So like I told you, user ID and group ID are provided for the each and everything. Fine, we can move ahead. So basically, when you install a application on iPhone, so this will be the content that will be visible to in a device, like the My App. Like similarly, some WhatsApp dot app will be there, and internal files will be documents, libraries, and temporary folders. Documents are basically that whatever images that will be get stored here, it will be available. Libraries are like the I told you .so kind of files, and temporary data is like it will be visible for limited duration. After that, it gets deleted, and further communication happens with the iCloud. Here iCloud gets involved as you get logged into the iPhone store. So any backup, anything you are storing, it gets stored on the iCloud by default. So you need to log in into the Apple stores for all these things to be done. Further, yeah, these things are given over here in detail, whatever I explained. So app name contains the bundle, contains the app and its resources. Document contains the file sharing thing and all. and further, this is the cache support and all. So this is all what I told you guys. Further, iOS basics. So what happened is zip application. So like for using Xcode, the application is being developed in Swift or Objective C. Then it is compiled and signed with the Apple developer account. So Apple developer account is needed if you want to start developing application. And by default, it's secure as no self-signed site certificates are allowed. So even for installing application on a device, you need to provide your device ID. Unless you provide your device ID, it does not get installed on your device. So when you log in into the iPhone Apple Store, by default it checks all this and gets installed. So jailbreak, basically the way you root on Android, similarly you can do jailbreak. Why to jailbreak? So basically is what happens is for a normal user, it's not possible to get into the backend how the application is storing data and storing data. Even if you want to customize your device, it's not possible. So like you can customize, you can change the carrier unlocking. You can after jailbreaking, you can increase your baseband, you can increase your network, but for that you need to create use a custom IPSW. Like you have custom ROMs for Android, similarly we have here custom IPSWs. So this is like a bit of complex thing if you want to try at your own risk. So basically after jailbreaking, you get access to the root file system. So root file system is like a pseudo user, like a super user privilege. So once you get a super user privilege, you can get into the how the application how the device is storing each and every detail of every application, that details we get in. Further, how to jailbreak, like yeah, how to check, like based on the iOS version that you are using, like 10, 12, you can visit this can I jailbreak link and check for the exploit or the code. But jailbreaking is once you jailbreak, you the Apple is not responsible for your device, you are only responsible, so do at your own risk. Further, there are two types of jailbreaking methods, tethered and untethered. Tethered require boot up. So what happens in the third, once the application battery reboots, runs down or tethered to your computer. So what happens is, even if in tethered one, when your battery, like when you switch off your mobile for iPhone, so what happens after restarting, the jailbreak is gone. And while in untethered, even after restarting or rebooting your device, still the jailbreak is there. So depending on the type of jailbreak you do, so this kind of things will be available. So after jailbreak, what happens is you like there is a normal Apple Store application, but once you jailbreak, you can like use open source and customize applications from another version of Apple. Like it is little bit useful for hacking or like vulnerability assessment. For normal user, this kind of thing is not advisable. So Cydia and Celio are basically the app store application stores other than the Apple's Mac Store. So these are bit untrusted, but when you have to do vulnerability assessment or security testing, this comes into place. So you can I say here I have written it's like alternative app store for jailbroken devices. After jailbroke, you can use this kind of Cydia and Celio. So you can install applications. You can like customize your customize applications, and you can try to log in using SSH and like protocol, this kind of protocol into application into the device, and you can try for something different things for the installing iOS applications. So it is very complex procedure. Even through Windows also, you need to set up this tool, box. This you can use to install application. But again, if that application is a bit secure, then you cannot install using iPhone and iTunes also. So it varies from application to application. While if you have a MacBook on using Mac OS, then you can definitely easily install application using the App Store, Xcode, and iOS deploy tool and the Cydia impactor. Fine. This is all from my side. Further, any questions and queries, let me know.
Yeah, thank you, Mr. Danish. As of now, I have not seen any questions. Dear participants, if you have any questions, kindly post it in the chat box.